About pulleys. So I've shown you a few examples of pulleys around the room. And a pulley is basically a wheel with a groove in it usually. A grooved wheel that has a string or rope that winds around it. And a pulley can be used in different configurations to do a few different things. Most often they allow you to use less force to lift a mass. When we're figuring out the ideal mechanical advantage, all we need to do, we don't actually need to use the formula. For a pulley, for the ideal mechanical advantage, just count the parts of the rope or string that are supporting the weight. So this one is a mechanical advantage of 6, because there's 6 parts of the rope supporting that. There's 3 types of pulleys. Okay, there's, I don't have an example for them. So this is called a fixed pulley. You have just a single pulley with one rope that runs around it. Now, how many parts of the rope are supporting this mass? Just one. So what does that mean its mechanical advantage is? 1. What does that mean? What would a mechanical advantage of 1 actually mean?
Oh.
It
doesn't reduce force, it just changes direction.
Yes, this type of, so mechanical advantage of 1 means it actually does not reduce the force that you need. Okay? You know, if something has a mechanical advantage of 2, okay, you can use half the force to get the object in the air. But with a mechanical advantage of 1, it actually doesn't reduce the force, but it does change the direction of that force. If you imagine this pulley, now instead of lifting this weight up directly, you could pull down on the rope and lift that weight in the air, but you still need to pull with the same force. But some of you said this the other day. When you're changing that to a downward force, what does that allow? Kaden? Yeah, for you to sort of use your body weight to pull that down. Okay, because you can use the force of gravity pulling on you to help lift that mass. Okay? So in this case, okay, we calculate our actual mechanical advantage. If this has a mass of 100 newtons, a weight of 100 newtons, it calculates mechanical advantage, RF over EF, which is what? Gives us 1. Now, does anyone see a problem with this calculation? Because I do. What would be a problem with this example that I'm giving, where the actual mechanical advantage is 1? Jack? Actual mechanical advantage. Luke?
Like, never mind.
Gabe?
Maybe the grooved wheel doesn't have like a whole lot of friction on it, so maybe
Right.
that could be a factor.
But will actual in the real world, will ideal and actual ever be the same? No. This really is an impossibility. The only way this could happen is if we had what?
Fixed.
No. A friction-free surface, which does not exist. So there should be some friction here. So what should this force be? More than 100. Slightly more. And what should the mechanical advantage be? Slightly less than 1. Okay, but that's not the way the example is set up. But you get the idea. Then there are movable pulleys. This is a movable pulley. Okay, if you have a pulley where the pulley is actually on the bottom, the top part is fixed. Okay, it wraps around the pulley, and the weight attaches to the bottom. This is called the movable pulley. And if you lift up on this rope, how many parts of the rope are supporting the mass? 2. 1 here and 1 here. This allows you to lift with about what? Half the force. Then we have this. This is a combination pulley. It has a fixed pulley on the top that's like attached to something, and a movable pulley on the bottom. It's like this one over here, and this one, and this one. These are all combination pulleys. Okay. And combination pulley, look at this one. What would its ideal mechanical advantage be? 4. 1, 2, 3, 4. Each part of that rope is supporting the weight. This would allow us to lift with a force of 25 newtons. Now again, what's the trade-off? Distance. So you're using less force to lift that object, but you have to do it for a much greater distance. If the pulley allows you to use half the force, you're going to have to pull it twice as far. If the pulley allows you to use a quarter of the force to lift the object, you're going to have to pull it 4 times as far. There's always that same trade-off in all of these simple machines we've been talking about. Okay. And you see that. To lift this object, because this has a mechanical advantage of 4, to lift this 200 kilograms up 1 meter, we have to pull 4 meters of rope through this pulley system. All right. We'll save levers. Any question about pulleys?